last time, we started looking at the concept of arithmetic operation. So we said a number of things. We looked at built-in constants, built-in functions, then order of arithmetic operation in MATLAB. We did some examples, and the course title is Process Modeling and Simulation. So in the way I teach you, I think I'll be adopting the approach of applying it to some of the chemical engineering problems that you may encounter. So now today what we'll be doing basically is to apply the knowledge we gained the last time to one of the case study problems that I showed you in the second class when I came. So it's about the rate phenomena problem. So based on what we have learned so far, we should be able to solve the rate phenomena problem. I'll just be giving you the theory behind it, which you may not know before, and so you could apply the MATLAB knowledge to it. So this is the question. It says that each conduction through a composite wall made up of two different materials. The thermal conductivity of the first material is called K1, and it has a value of 0.5 watt per meter Kelvin. The second material, the conductivity is 0.2 watt per meter Kelvin. The thickness are 10 centimeter and 15 centimeter respectively. So that means the first material is 10 centimeter thick, the other one is 15 centimeter thick. The temperature at the outer surface of material 1 is 100 Celsius, and at the outer surface of material 2 is 25 degrees Celsius. So you are asked to calculate the temperature at the interface between the two materials and the heat flux across the composite wall. So what are we saying? You have two materials. Okay, the first one has a particular conductivity as stated. It's being amalgamated with another material that has another conductivity. Not just that, their thickness in that composite material is different. So we have been given that. So we are told that material 1, it is moving through it and it has a temperature. Then at the interface, the temperature would have changed. That's what you are looking for, the interface of the two materials. And you are also giving the temperature at the outer surface of the second material. So those are the information that you are giving. So the first thing, like I've told you, is that you understand the problem. I've described it to you. I've demonstrated it to you now. Then you understand what's the principle behind it. So the principle that applies here is the Fourier law. So I'm giving that to you. It's the Fourier law. Then I told you that the next thing is that you want to represent the problem pictorially so that you know what is actually happening and what you can do. So I've represented it as you are seeing on your screen. So the first compartment, I've labeled it material 1, and I put the value of the conductivity for that material there. Then we have material 2 in the second compartment. Then what is joining them together is the interface. So it is that temperature that you want to know. I think I labeled that one INTF. Then the temperature at the outer surface of the first material, I have labeled that one T1, which is what we are giving to be 100 degrees Celsius, right? And the temperature at the outer surface of the second one is T2. I think we are giving that to be 25 degrees Celsius. Now material 1 is 10 centimeter thick, material 2 is 15 centimeter thick. So you see the length, the difference in length, the way I represented it, just to tell you that one is thicker than the other. Okay. Then the heat that is flowing, the heat flowing is the Q. So it's flowing through that material like that. So once you have that, the next thing is that you set up your Fourier law mathematically, then you solve. Now you solve with MATLAB. So let's set it up. So based on that picture and what the problem has stated, you know that the heat flux is the same through the material. So you have heat flux from a source moving through the material. So that means Q, which is our heat flux, is the same thing as Q1, which is the flux that moved through material 1, and equals to Q2, the heat flux that moved through the second material. So the Fourier law is what you have seen on the board. It stated Q, which is the heat flux, equals to minus K dt dx. K is the conductivity, thermal conductivity of your material. dt is the change in temperature that is going to happen. Then the x is the distance through which the flux is moving. So in this case, it's going to be the thickness of each of the material. So if you apply the Fourier law to each of the material, so we have used K1 to represent conductivity of material 1. We have said the interface temperature to be T interface. So temperature at the outer surface of material 1 is T1. So if we interpret that based on the Fourier equation, so dt is change in temperature, right? So we say the final temperature minus the initial temperature. So in the case of material 1, what's the final temperature in that context? So it's going to be T interface. So what it started with was T1. So in this case, it's going to be T interface minus T1. Then the thickness is L1. So if I say this is 5 centimeter, before I can say this is 5 centimeter, I must have started from a reference from a datum, which is 0. So that is why I said the change in thickness or distance in this case is L1 minus 0 for the first material. So we replicate that for the second material. So everything that is 1 becomes 2. But in this case, the starting point is going to be, what's the starting point? It's going to be T interface. And the end point is going to be T2. So that's why the change in temperature now is T2 minus T interface. Okay? So I've interpreted my Fourier law. We know that, or I have told you that Fourier law is what applies to that problem. And we have interpreted it for each of the material. Okay, so since the heat flux is the same in the two materials, so that's why we are able to equate the first set of equation to the second set of equation. So now your business is, you are looking for the interface temperature. So based on your maths, you know what to do, that you have to make the interface the subject. So that's why you have the next equation here. You can see where my cursor is hovering. So you can do that. So that's your T interface. So we've been given K1, you know your L2, you know your T1, K2, L1, T2. You know all of these variables. So that means by now you can now use your MATLAB. So this is just looking like an arithmetic, which is the application of what we have done or we started doing the last time. Okay, but it's not only the interface temperature that you are asked to calculate, you are also asked to calculate what? The heat flux. So once you know the interface, which is the unknown in this set of equation, then you can use either of the two set of equation, either the one with either the equation set up for material 1 or the equation set up for material 2 to get your heat flux, right? Because your K equals to minus K1 into bracket T interface minus T1 divided by L1, or you could set it to equals to minus K2 into T2 minus T interface divided by L2. So once you get your T interface, then you can calculate your heat flux. So that's about it. So it's just algebra. But you must have started from your engineering knowledge that what theory applies to this problem. When you know the theory that applies to it, you interpret it mathematically. In interpreting mathematically or in determining what you are supposed to do, you could set up a diagram like this and you proceed from there. So now that we have said that, let us solve. Okay, I think we can start solving from here. So let's go back to our MATLAB. So what do we need to do? The first thing is that you want to, depends on how you want to approach it. Well, at least we need to know what are the variables that you are given. You need to declare the given data. Then we have told you that as strategic positions to put comments that can be helpful. I might not be able to give detailed comment in the class because of time, but you know what to do and you can work with my notes. Then when we declare the variable, then we might want to state the Fourier law sort of as a comment so that the person knows that this is the background to this solution. Then when we state the Fourier law as a comment, then we can move to our equations that will help us solve the problem, typing them out and executing them. So should we begin with writing the variables that we are given? Let's begin with that. So I think I will have to divide my screen into two to get the values. Hopefully it's large enough for the class to see. Okay, so I want to use script. I'm not using the window command directly. So what are we given? What are the variables? We are declaring giving data. Well, let's start with K1. So I can say K underscore 1 equals what? What does it equal to? 0.5. So let's put a semicolon. So you at the side, you might want to comment that the unit is what? Watts per meter Kelvin. Okay. So we have K2, right? K2 is 0.2. What else are we given? We are given the thickness, so we called it L1 and L2. So you can continue with the comments. T1, okay, L1 rather. L1 is what? 10 centimeter. If you recollect in your CHE334-MATLAB-ARITHMETIC, okay, we are told about consistency of your unit conversion. So you know that this is centimeter, but your conductivity has a unit of meter. So that means that thickness also has to be in standard units, which is meter. So that means you need to do some conversion there. So instead of 10, it should be 10. If you want to convert centimeter to meter, I think you should know that. So that's our thickness. Then we move to L2. So if you just put 10, the computer will give you solution based on that. But is that what you intend? So those are the things you put into place while solving your problem. So what other things should we declare? We should declare temperature. Temperature is, in the first case, is 100 degrees Celsius. Okay, ordinarily, you should convert Celsius to Kelvin, but it wouldn't matter because what we are doing here just has to do with difference. But if you will be doing something raised to power something and all of that, it will matter. But it's just the normal difference. For example, if I will convert this to Kelvin now, I just have to add 273 to it. 25 degrees Celsius, I had 273 degrees to it. So when I want to get the difference, it's still constant. So I hope you know when to overlook conversion of temperature and when to enforce the conversion. Okay. Do you have the complete data set? So we have the given data set up. So we are looking at T underscore high. So to get that, we need to know what is the equation that is applicable. So what is applicable here is the Fourier law that says Q equals to minus K So I hope you understand what D means in this instance, because we have established that dt, dx, Fourier law. So we have broken the Fourier law into a set of equations that we now need to recollect now. So we said at the end of the day, it is going to yield for us T interface is equal to K1 L2 T1 plus K2 L2 T2 divided by K1 L2 plus K2 L1. So at the end of the day, so that is what we need. So we can say T interface represented by Ti in this instance. You determine what you want to use to represent it. Equals K1 multiplied by L2 multiplied by T1. Okay. Okay. So anybody with the answer? Anybody with the answer? has the answer, please? Anybody will answer? Yeah, we are looking for persons that have done it. So anybody with the solution? You have the solution, Michael. Okay, so we can move on. What's the next thing? The next thing is to find the flux. So we said we could use any of the equations, maybe for material 1 or material 2, to set up the flux. So let's use Q to represent the flux. Okay. So I'm using material 1, another person can use material 2. So let me run it. Alright, let me ask you to display. Okay, what's the issue? Unrecognized K1 underscore, okay. So we had K underscore 1. T also is T underscore 1. L1 is L underscore 1. That's the official name that we have given. So that is what, those are the variables we can refer to. Those are the variables we created earlier. So let's display Benita, do you have the solution? Where are you? Continue your work. So based on the equation we set up, what will be the unit of our Q? Can you speak louder? If I commented what? For the, would you have displayed them? So what I've done this morning is just to use display to display only the variable that I want. You see that the only thing that I passed into it is the values that I want, because I'm trying to manage time. Okay, so if I want other things to be displayed, it's not about my comment, it's about typing what I want it to display. So let's see, maybe I could have said f print f, then all of this should be in quotation. this is double. Okay, so let's see what happens. If I run it again, let me clear what is here. So you decide how your result is displayed. So it's not about the comments, no. It's about how are you telling me to present your results to you. So let's move to the next thing that we have here. So how many of you solved the problem that we just did? Okay, did you get the answer? The answer I got. Did you get the same answer as I have for the two variables? Okay, so that means we should give the next question a try. So let's look at this problem. You have two equations. AN plus BM equals to B. The second equation is ACN plus BDM equals to F. So let's say you want to solve this set of equations using elimination method. You know, it's a simultaneous equation. It's a simultaneous equation. So if you want to solve using elimination method, can you write in form of comment? Right, let's ignore the values that we are seeing on the screen. So let's say there are no values displayed on the screen. Okay? So can you comment like the steps, the code that you would have used to solve it? Ignore the values that you are seeing. So you have those two equations and you want to solve by elimination method. So what would you do? I have taught you the MATLAB, how to apply some stuff, but in solving problems, you have to do the thinking. You have to come up with your own ideas and apply one or two things that you have known that is applicable in MATLAB. Okay? So, in form of comment, so how would you have solved it? Just your normal mathematical thinking, what would you do? So write the code and let me have it. This is not because that you memorize something and come and pour it down. At least I've shown you, for you to know that it's not really about memorization. You can seek help. Like I wanted to confirm my display, that if it could take some other input apart from variables. It was in your presence that I looked it up. So if I was connected, I would get more information. So it really is not about memorizing, it's about the way you think. So write some comments to show us the step you would have taken to solve this by elimination. Any ideas? Okay. What? Please let me see. Alero, right? Okay, so let me see the equations you actually wrote.
You can, no, I just wrote the comments first.
Okay, you have tried. Now, yeah, as you have written this pseudocode, now the next thing is a good step. When you have a pseudocode, the next thing is now you now represent this with maybe letters. You said make n the subject. Let me see the equation. Okay, you don't have the equation. Okay. Substitute. Yeah, it's a good step that you wrote the pseudocode. But if you want to do elimination method, I think what we would have done is that to eliminate, we need to make some parts equal.
I want to use substitution.
No, I said elimination.
Oh, okay, that's true.
So this pseudocode, if we are using what did you call it? Substitution method. You now turn this into letters, variables. So you said you want to make n the subject. So you now look at the equation. So n equals to e minus bm slash n. You write it as a comment. Why are you going to write it as a comment? Because you have not provided values for any of those variables. Okay, but it's the right step. This is like a pseudocode. Then you now represent in the letter. So that's what I mean. Okay, so let's quickly look at my solution before I leave the class. So what would we have done if you want to solve by elimination method? Those two set of equations. Okay. Quiet, please. The first thing is what? We do what? You have said. Okay, so which one do you advise we multiply by a factor? Okay, so what are you suggesting? There are at least two factors we could have used. D. Okay, so you did by D. So the solution I have is by C. So we are going to get the same thing. So now if you multiply by a factor, so let's say C in my own case. So that means E is no longer going to be E. It's going to be what? CE. So let's name it. Let's give it a name so that it's easier for us to handle. So let's call it EFG. Let's call it G, right? So that means if we multiply by C, we have another variable created, which is G. So G is going to be equals to ACN plus BCM, right? Equals to G. And your G is what? E times C. Okay, so let me copy that out. So in just writing the pseudocode, what would you have done? That's what it's about. So let's go back to where we were. So I want to clear this. So this is the equation. Okay, it's not complete. We had two equations, so we can look at the equation and know what to do. So someone suggested we multiply by a factor. So you multiply by D. Let me multiply by C. So we are going to get to the same place if you actually did it correctly. So the first step is that we multiply by a factor C. So if I'm multiplying by a factor C, I know that E is no longer E, so it's a variable now. So I call it G because I'm assuming I don't have values for any of the variables. So I call it G, and that same G is equal to what is on the left hand side multiplied by C, and this is what I have written here. So that's why I have two lines for G. So when I have done that, what's the next thing? I have multiplied the first equation by a factor. So what do I do next? The guy that was guiding us, what do we do next? So we have multiplied by a factor as you have suggested. What do you suggest we do again?
Then we can now subtract this f from g.
So the next thing is that we subtract. So you can put the comment at the right place. So to guide you, so we can say we want to subtract maybe 2 from 3. Or you can say you want to subtract 3 from 2. You just know that you are subtracting in order to eliminate the part that is now equal. So when we subtract, you know what is on the right hand side will no longer be the same. It's going to be a value, right? So let's also name that value, right? And that value is going to be the difference between what was on their left hand side. Okay, so let's call that variable h. So here, what did we do? We multiplied by a factor, a reasonable factor. You know what is reasonable? To make at least one term equal. So that was what we did by this step. So the next step is that we should subtract. So we want to subtract the term that is equal. So this is a comment. So now that we have subtracted, so what do we do? Hello, what do we do? After we have subtracted, what do we do?
After you subtract, that would be the g minus h. Sorry, minus f. So you can call g minus f and tell you new variables.
Yeah. So we have done that. So what do we do now?
We now make c. I think it was MUD. Was it MUD?
So we have variables we are looking out to get. Variables, is it m and n? Okay, so from there, tell me what to do next.
You make the unknown that is there.
So we make it the subject. So what do you suggest we make the subject of the formula? Okay. So make a variable the subject. So he has suggested that we make m the subject. So in making m the subject, you have to be sure that what are equal have left the system, so that it's easier for you to make m the subject of the formula. So this is we making m the subject. So when we make m the subject, so that means we can get the value of m. If we get m, what else can we do? Yeah, we can use the first or the second equation now to find the other one. But I think it's easier to use the first equation looking at its simplicity compared to the other one. So those are the steps you would have used if you want to solve. Okay, so now that we know the route, so in solving for m, you need to know what your g is, need to know what your f is. You have been given other variables, and once you get your m, you can get your n. So now we can put in the values that we have been given, the variables that we have been given, the variables a, b, c, d, e, f. So now that we have the formula, so if you look at the last two equations, you know that we need to get g, we need to get f, and we already have a simple equation for that. That's equation 3 and let me call this equation 4, so that so this is equation 4. So since I have values for C and E, I can get my G. I can uncomment my G. Then once I get G, I can get H, right? I can get H, so I can uncomment that. So once I uncomment it, then I can compute my M, because G and H are now available. Then I can get my N. So that's what you need to do. That's the step. So it's still about applying the arithmetic operation that we have said earlier. So now that we have that, so let us state the given variables, the given data. So what are the given variables? Given data. Our given data is A, B, C, D, E, F. So let me get that. So now I don't have to put this in comments because they are now actual values. We are done with the first set, the first part of the question. So the other part is, okay, now you have these values. Get the unknown for us. So the values that we have been given, A, B, C, D, E, F, don't have to be in comments now. So now what I have written, some of it I will now uncomment it. The first one that I will uncomment is my G. So G is E times C, right? Semicolon, because we are working with script. Then our H is what? G minus F. Semicolon. Then we get the equation for our M. Okay, so we can now run and get the values. Do you have the values?
I think I am on the comments there.
Yeah.
I stopped. I uncommented. I think I did something wrong because it's telling me it's not representing variables.
Oh, okay. So let me run and hopefully this one works. Line 6. So what's happening in line 6? Line what? Line 31. Oh, the letter is not written correctly. Thank you. What was there? I think that was... E minus B. E minus B. So that was because we are trying to save time. Okay, so let me run again. So the solution is in our workspace because I have not asked it to display it, but let me ask it to display so that you can see it displayed there. We are displaying H, displaying G, N. Well, let's start with M and N. Okay. So solution. So you can try using, I multiply by factor C. So you can write your own set of code using factor D, and you still arrive at the same thing. So it's just to teach you how to think algorithmically, and also to apply the MATLAB as a tool. Any question based on what I have done today? So we should continue from here the next class. I might not put my own code so that it's not that I'm giving you handouts. You should be able to think independently and come up with your own solution. So I have done C in the class, explain what we did. So you too, you should try and do D. And I expect you to get the same value.